Hello, I have the upper two axes of the CNC machine assembled now. It's not a permanent assembly, just for testing. I mainly wanted to see how well my worm screw brackets were fitting, and to make sure that there wasn't too much friction for the stepper motors to be able to turn them enough. So that seems to be working out okay. And along the way I also played around with the controller for the stepper motors as well. So most of this episode I'm going to have a look at how the controller for the steppers work, and we'll see a little bit of testing of moving these axes up and down. As I think I mentioned before, I already had one of these stepper motors around. It was just one of these things that I bought once upon a time to play around with for no particular reason, but now it has a purpose. And my first attempt to get this doing some stepping was with one of these L298 modules. They're pretty cheap, 298N I suppose officially, and this is here, that's where I got that, so it's only $3. It turned out to be not the best way to do it, because when I tried turning the motor, and it works and everything, but I'm not exactly sure what it's doing, but it keeps current flowing through the motor even when it's stopped. So you're just sitting still doing nothing and it gets hot. It gets really, really quite hot. So I immediately started to look around for more intelligent ways to do it, and I came across this one, and this is what finally tipped the balance for me between deciding whether to do this project or not, because I'd been a little bit scared of this side of things, having not done any of it before. But like most things, if you take it one step at a time, it's not too hard. And anyway, the price also was very, very attractive. So you actually get an Uno R3 knockoff, of course. It's not an official one, and you also get this shield that goes on top of it. So you get one of these geek right ones. Actually, I'm not sure if this is the exact thing that I bought, but it was about that same price. I don't remember this geek right name at the time, but anyway, it's just a Arduino Uno clone, and on top of it you put this thing, and then on top of that, for each stepper you have this A4988 stepper driver. So we'll have a look at that in a fair bit of detail in this video, and I'll show you how I went about getting it up and running. So here is that stuff here all assembled, and this is pretty much what you get in the set. You do not get these wires here. I've just attached a JST to power it from a LiPo, but you do also get a USB cable with one of those connectors, and you get the fourth A4988 module, which I have not attached because, well, I'll have to do that actually, because I'm going to have 4 steppers now, but originally I thought I was just going to have 3 steppers, so I'll stick that one on later. But just have a look at this. 4 connections for your stepper motors onto the pins at each side of the, or on the sides of each of these stepper driver modules. And a lot of these other pins here I think are just passed through from pins on the Arduino. Are they? Actually, I'm not sure how it works. But this gives you a lot of breakouts to attach limit switches on here. You can have one switch at each end for each of the 3 axes. So this shield is made to implement the GRBL system of passing G code through the serial connection to control the stepper motors. And at the moment this is only for 3 axes. That's why it's all specifically set up with 3 axes. And the 4th axis you can clone one of the other ones, which is what I'm going to need to do for my design, which uses 2 motors for the y-axis. So that's what this GRBL thing is all about. So that's why there's only 3 axes there. And you also have some pins down here which I think you can use. They'll probably just go high to enable the spindle or change the direction. And if you have a coolant pump of some kind, it looks like you can turn that off and on using the G code as well. And then these 3 here, abort, hold and resume, I think you can attach a switch to those so this would be a digital input, whereas these okay, so the first 6 will be digital inputs, these 3 will be digital outputs, and then these next 3 will be digital inputs again, and the last one, emergency stop, will be a digital input as well, I guess. So these can have push button switches to pause the program while it's running or abort it, I suppose was what emergency stop does. Then over here, these ones here, step and direction, these, I think you could use these to, you don't need them if you're controlling it from a computer, because all the instructions to control the steppers will be coming in through this cable over the serial connection. But if you wanted to have a different microcontroller, like if you were not using the, oh yeah, there's an Arduino on the bottom, of course. If you were not using the Arduino on the bottom, then you could have a different microcontroller giving inputs to these pins to give pulses to the stepper motors to turn them and say which direction they should go. And then there's a reset button, and then, oops, oh that's right, it's okay. And then there's a 5-volt and ground there, which I guess might be useful. And then over here we have an input which is going to be the power for the stepper motors, and that's 12 to 36 volts. I have already tried this a little bit, and I've been running it off a partially charged 4S LiPo at about 15 volts, and the stepper motors that I have seems to be okay with that so far, even though they're only rated for 12 volts, I think. So on each one of these stepper drivers there is a little potentiometer that you can use to adjust the current limit. So these are a little bit more intelligent than the other one, this thing that I was just looking at, which is kind of dumb. And these do not run the motors hot when they're not doing anything. Not so far anyway. I haven't put it through much load, but so far nothing seems to be getting hot at all. Although if I look in the documentation, these chips themselves can get quite hot, and that's supposed to be normal from what I've heard. And there's a little fuse down in there, a little bit hard to see maybe. Not sure what current rating that is, but I think these modules are rated to 2 amps. So maybe that's a 2 amp fuse. I'm not sure. And then we have some jumper pins here, which I will explain in a minute. I didn't know what they were for at first, but they have come in very handy, or almost essential really for what I was doing. So we'll get to that in a little bit later. And we can see that each one of these modules is labeled with which axis it's going to be controlling. So that's the Z, Z, X, Y, and then A, which is going to be, in my case, cloned from the X. So these two are going to be outputting the exact same signals. Speaking of cloning, I almost forgot this little section over here, which is, so we've got X, Y, Z, and then we've got D12 and D13 there. And these are jumper pins which you will connect to choose which of the axes you want to clone onto the A axis. So in my case I want to clone the X controls this one, so these are going to be exactly the same. So I would put a jumper across the 2 blue pins there at the top row, and then across the 2 yellow pins as well. So there'll be 2 jumpers there. And although the GRBL does not support separate control of a 3rd axis, if you wanted to control this stepper motor separately from the others, so you'd have 4 actually independent axes of movement, you can also, you'd need to change the program that's running on the Arduino, of course. You have to write your own program to do it, but there is the possibility for using pins D12 and D13 to control the direction and the step that's sort of under that plug there, so you can't really see it, but I think it says step because it'll be like this. So A step direction. Actually, if it's A step direction there, I wonder if these step and direction are the same pins for as that. There might actually just be the same pins showing up there. Or maybe you've got a jumper across these 2 blue and those 2 yellow to do it. I don't know. But anyway, it doesn't matter. So for my case, I think I'm just going to jumper across the 2 blue and the 2 yellow at the top row to clone the X-axis onto the A-axis. And there's one last thing which I'll show you on this board, and that is a URL which is very useful, info.protonea.com/1, and that's what I looked up to figure out how to get started using this. So let's have a look at that. If you look at that URL, it'll take you to this page, and yeah, it's a description of this thing, written by the guy who designed it by the looks of it. And there are some older versions which we're not really interested in. There's this picture which I think they copied onto Banggood, and then there's some what was I going to show you down here? So it's a sort of an open source thing by the looks of it. He has listed up what you need to make it and the circuit design as well, and then assembly instructions and so on. Now what I wanted to look at was this, the GRBL Arduino library. Use the Arduino IDE to flash GRBL directly to your Arduino. So if you click on that link, you'll be taken to this page, and there are some pretty simple step-by-step instructions here about how to get the right program onto your Arduino to start using this. However, I found that this one here that he's directly linked to as a zip, this one did not work for me. I didn't really bother to figure out why. The rest of the instructions are okay, but instead of using this zip file that he's linked to, I just googled for GRBL, GRBL, and this was the first result here on GitHub as the repository for the, I guess this is the main official repository for this. There's a whole lot of information here about how you can set it up. Actually, no, it's not here. There's a wiki somewhere. There's a wiki, which I'll look at in a second. But to get this into your Arduino IDE, what I did was I clicked over here and I did download zip. And inside the zip file, you'll find all this stuff. And this folder here, which is GRBL, if we look in here, we'll see that this is the actual Arduino library. So it has the examples folder and all the source code there. So if you unzip the zip file and put this folder into your Arduino libraries folder and then restart your Arduino IDE, you should see in your examples list, oops, there should then be a GRBL upload. So if you open that sketch, you'll see this is it here. It doesn't actually do anything. It says there is sort of something you can customize, options for customization and features and so on, but I didn't bother with that. So all I did was just compile this program and upload it onto my Arduino. And then if you open your serial monitor, you'll need to set it to 115 kilobits per second, so 115200 baud. And if you choose that, it will reboot. Well, so every time the Arduino starts, you're going to see this sort of initial message here in the serial monitor. So let's go to the wiki, which I think is my next tab that I have here. Yeah. So in this wiki is where most of the info is found about how to run this. And I've only really done a few basic movements with it so far, but I'll just point out a couple of things here. GRBL, as I said before, is for 3-axis machines, no rotation axes yet, so just X, Y, and Z. And it's able to maintain a 30 kHz step rate, so it seems to be quite capable, at least for basic control of stepper motors. And it lists here the G-code commands that it knows about, or knows how to implement. So all I've really done at this point is G1, which is a basic linear movement between 2 points, linear motion. So that's all I'm going to look at in this video. But you can see here there's a few other stuff, a few other commands that it knows about. and it looks like we can use M3, M4 and M5 for, maybe this could actually be used to turn the spindle off and on as well, so that could be quite handy to turn it off. So if you want to go away and leave it and then have it turn the spindle off when it finishes the jobs, that would be quite handy. Same for coolant, if I ever get to that. Yeah, but anyway, this is the main page for that. But I didn't really read that too much because I saw this link here where it says G-code quick reference, and this lets you see the format for the G-codes that you can use to tell it what to do. So if I click on that link, you'll find this page, which is, this is going to Linux CNC now. So this is the official formats for this G-code standard, and this GRBL shield, or the GRBL system, implements just some of these. So that's why we had this list here showing you that it's only going to do some of these things from the Linux CNC standard. But anyway, if we look in here at G1 linear move, and this gives us a little bit of an example about how we can do this. So G90 to start with will make sure that whenever you tell it a location, for example in the next line here we've got X 1.2, if you say G90 to begin with, then it's going to be an absolute location rather than a relative location from where you start. So let's have a look at that over here. Well, why don't we explore this a little bit first, because it's got a little help for us here. So if I type a $sign in there and hit enter, I'll see a little bit more info about what we can do here. So I'm talking to this thing here now through the serial cable, and it's interactive in this way, so it'll give me a little bit more help about what I can do. So $, will view the GRBL settings. I haven't really done anything else, although I have tried this question mark. So try the question mark to start with. It'll tell us what it's doing, and it's doing nothing, and it'll also tell us where it thinks it is in those three axes. So because we've just reset the Arduino before, it thinks it's at 0, 0, 0. I'm not sure what the difference between M and W are. Maybe if I figure that out, I'll put an annotation on the video. But anyway, it thinks it's at 0, 0, 0 in both of them. And the $, to view GRBL settings will show us this list of things here, among which I found that the most important ones are steps per millimeter and acceleration and the rate, maximum rate. Actually, mainly the steps per millimeter is the most important one, because you need to tell it how many turns of your stepper motor it's going to take to cover 1 millimeter of travel in the CNC axis. As it turns out, I ended up leaving this at 100, but I tried a few things before that which didn't go quite to plan, and I ended up back at 100 for reasons which we'll see in a short while. Yeah, actually, as it turns out, I ended up being able to leave all of this as the defaults. But if you do want to change something, for example, let's say your stepper motor was set up so that 25 turns, or 25 steps of the motor would cover 1 millimeter of travel in the x-axis. So in that case, you'd need to change this from 100 steps per millimeter to 25 steps per millimeter. So the way you do that is you take this number here, $100, and you say, what did I say? 25. So you can set that variable to 25, and it will say OK, and then if you do the $, again to see, to get that list back again, you'll see now it says 25. And this will be stored in the EEPROM. So if I reset the Arduino, and then we do the $, again, that 25 is stored in the EEPROM, so we didn't lose it by resetting the Arduino. Which one is it? 100. I'm just going to put it back to 100, which was what I'll eventually be using. Okay, so it's back to the default. Yeah, so that's how you change those settings if you need to change them. And then, as we'll look at in a moment, to actually move the motors, you need to give it one of these G commands. So, for example, linear move. To make it absolute coordinates, you would do G90 to start with. I found that it seems to be absolute coordinates to begin with, though, so whether you do G90 or not at the beginning doesn't seem to matter. But maybe to be safe, that's a good idea. And then, so to move it 10 millimeters in the x-axis, you would go, oops, well, not to move it to the position 10 millimeters in the x-axis, I should say, because we're using absolute measurements here. You would go like that. Oh, and then it says undefined feed rate, because at this point I haven't told it what the feed rate should be. So let me try that again. So it's G1, 10 millimeters in the x-axis, and the feed rate should be, let's say 300 millimeters per second. I think those are. Millimeters per minute the feed rates are. So 300 millimeters per minute. Let's try that. This time it says OK, and if we do the question mark now, we'll see that the position that it thinks it's at is now 10, 0, 0. So nothing's happened, of course, because there's no there's no motors connected to it, so nothing's happened. But it doesn't know that. So in its little brain, it thinks that it's moved 10 millimeters in the x-axis. This one's changed as well. I'm not sure why there's two of these positions. But anyway, that's how it works. So we'll see in a minute when I actually connect the motors up that it will move the thing 10 millimeters in that direction. What else have we got here? Yeah, so if you want to give it other axes, like you could go X, well, move another 10 millimeters in the X, and then move 10 millimeters in the Y as well. And every time we do this, we could add an F to change the feed rate as well. But according to the docs here, this time it says linear move at the same feed rate. So unless you want to change the feed rate, you don't really need to add it. So this time I don't need to put the F part. And it says OK, and if we do the question mark, now we'll see that it thinks it's at 2010. And that's about all there is to it, as far as I can tell. It's quite simple, although, well, this is a linear move, so it's quite simple, but when you start looking at all these other things like arcs and helical motions, then it's not so simple. And that's why we have a CAM program to calculate this stuff and convert our CAD design into this G code, so that we don't need to worry ourselves thinking about it. But anyway, I've probably talked enough about this, so let me show you what I did earlier, connecting this up to a stepper motor and getting something moving around. Okay, I have the motor set up with the GRBL shield ready to do some test movements, and it sounds pretty bad, very sort of clicky sounding, not very smooth at all. Let me just run a 5 centimeter movement here. And part of the problem is that those little screws under there, maybe you can just see them under there, they are not Loctited in, of course, yet. I'm just sort of dry fitting everything, and they tend to work their way loose and start rattling, so that's part of the noise. But even without that problem, the motor seems to be very notchy feeling. It just doesn't seem to be moving very smoothly. I think having it sitting on the desk is also amplifying the noise, making it sound a little bit louder than it is. But even with the rather stiff movement or the stiff friction on this screw, the motor doesn't seem to have any trouble moving it. Of course, there's no real load on it though, so remains to be seen what happens when it's actually trying to push through and cut something. It looks like that is not so much a problem in the structure as it is in the control signals that are being given to the motor, because if I run it with no load, like absolutely nothing on there at all, we can see it sort of stuttering and stuff. And I saw this before ages ago when I was playing around with these. I can't remember what I did to fix it, but it could be perhaps that I've got these plugs around the wrong way on the motor connections, but if I change them around it gets worse. So not sure what that is. Okay, I've been playing around with this a bit more and looking at the documentation for these A4988 modules, and I've come up with something that is much better. Not sure how it will go when it's under load, but it looks and sounds a lot better for now. So what I've done is I've put one of these jumpers across, so you can see there's a set of 3 jumper pins there, and this lets you select micro stepping rates, so half step, quarter step, all the way up to 16th step. So if I just put this over here, so there's this little table here that shows you how you can select the steps for that. So I've put it in the middle one, which is going to be quarter step, and then for these settings here I've increased my steps per millimeter appropriately, actually using this Z axis there. I'm not going to focus, but it says Z or Z, whatever. So I've increased that by a factor of 4, and now it's running quite nicely. So let me just do say 50 millimeters, and then I'll move it back all in one go. So this is looking and sounding a little bit more like it should, I think. Nice. Fits in there just nicely. I'm just trying out 2 motors together now. I've attached the second set of brackets underneath for moving this plate, and we can move them together like this. And everything seems to be okay. It's very nice and tight in that way and that way, and this way as well, but this way's like that way is a bit of a problem still. Still feels a bit soft. When I was trying to fit the lead screw underneath the Z-axis plate there, I had a hell of a time getting this pillow block to fit in there, and as you can perhaps see from this angle, the problem is that the axis of the bearing is actually off. So instead of being horizontal, it's a little bit up like that. So unfortunately I'm going to have to buy, actually there's another one that's a bit like this too, so I'm going to have to buy at least 2 more of these and wait for them to arrive before I can get much further, unfortunately. While I was playing around with these G-code things, I thought I'd try just a couple more of these commands before I finish up. And if we look at the bottom, there is a coolant control, M8, M9, and if I look at the G-codes page here, I notice there's an M2 there at the end, and when I click on here you can find a different page which is called M codes, and if you look down here we have M7, 8 and 9 which are related to coolant. And I tried this on here, and I have a couple of plugs there on the coolant enable pins. So the one on the outside, the black one, is ground. The one on the inside is going to be either 0 or 5 volts by by the looks of it. At least that's what seems to be happening. So if I try this, and what was it, M8 I think, to turn it on? Yeah. So when I do M8 we get 5 volts then on the on that pin, and if I do M9 it goes back to 0 approximately. Interestingly, I could not do that with the spindle enable, which is just a couple of pins above, SPN-EN. I thought that would do kind of the same thing because it has pretty much the same codes here. So we've got M3 start the spindle clockwise and M5 stop the spindle. That's the ones I was trying, but they didn't do anything. And it's permanently high, so it permanently seems to be getting 5 volts out of that spindle enable pin. So I'm not really sure what the issue is with that, but I could potentially use the coolant enable to turn the spindle off and on. I'm not really sure how that would work out, but there may also be a way that I could use both of these as proper switches to turn things off and on. But I'll cross that bridge when I come to it, I think. So the last thing I wanted to try before I finish up is to see if these buttons for pausing and resuming the job are going to work. So I've got a wire on here on the hold connection, and I think this is supposed to pause the job. I'm just going to connect these together to form a switch as the motor is moving, and I'm presuming that that's going to stop it. So let's see what it does. Okay. Touched again. Okay, so that's just a one-way switch to pause it. And then if I put it onto the resume, so I've just shifted it across or down one set of pins, and then presumably this is going to start it again. Cool. Have a little switch in between here, by the way, just in case it goes wrong. I can turn it off like this. But anyway, that's pretty cool. I'm quite happy with that. So far, everything seems to be working quite nicely. So when I get those other pillow block pieces in, then I'll be able to continue with building this. So until then, thanks for watching.